write a function fib n that takes in an integer n and returns the nth Fibonacci number. So here, Fibonacci numbers are a series of numbers that start with 0 and 1, and where each number is a sum of the previous two numbers. So this is how the first few Fibonacci numbers go. So here, by default, for n is equals to 1 and n is equals to 2, our numbers are just going to be 0 and 1. And from n is equals to 3 onwards, each number is the sum of the previous two numbers. So here, 1 is the sum of 0 plus 1, 2 is the sum of 1 plus 1, 3 is the sum of 1 and 2, 5 is the sum of 2 and 3, 8 is the sum of 3 and 5, 13 is the sum of 5 and 8, and so on. So essentially, if we pass in n is equals to 10, we should get 34. So do pause this video and take a while to give this a go before taking a look at the answer. So here, we firstly define fib, and it takes in an integer n, and we have a colon, and here we write our function body. So before we jump right into writing our function, let's take a look at how our function will work. So firstly, we can take care of the edge cases. So if n is equals to 1, we return 0, and if n is equals to 2, we return 1. However, we have to do some calculation if n is 3 or above. So here, the simplest way is to generate all the Fibonacci numbers at first. So we are going to have 0 and 1. So let's say n is equals to 3. So we take 0 and 1, and we find the sum of the previous two numbers, and we get 1. And we take this 1 and we add it to the end of our list. So afterwards, our list becomes 0, 1, and 1. And here we have generated the third Fibonacci number. And if we do this once again, we take 0, 1, and 1, and we take its last two numbers and we add them together to get 2, and we take 2 and we add it to the back of our list, we will get 0, 1, 1, 2. And here we have generated our fourth Fibonacci number. And once again, so let's say we have 0, 1, 1, 2, and we take the last two numbers and we add them together to get 3, and we add 3 to the back of our list. And afterwards, we are going to get 0, 1, 1, 2, 3. And once more, if we have 0, 1, 1, 2, 3, and we take the last two numbers and we add them together to get 5, and we add this number to the back of our list, and we'll get 0, 1, 1, 2, 3, 5, and so on. So here, notice that we are actually generating the Fibonacci numbers list here. And for n is equals to 3, this happens once. For n is equals to 4, this happens twice. For n is equals to 5, this happens 3 times, and so on. So with this in mind, we can start writing our first version of our function. So here, if n is equals to 1, we return 0. And if n is equals to 2, we return 1. So these are the default values. And next, we have a list. So we start with 0 and 1. And for I in range, so here I'm just going to put n first. And next, we are going to take the last two numbers of our list. Okay, so last is equals to list minus 1, and second last is equals to list minus 2. So here, next we have a new number is equals to last plus second last. And afterwards, we simply add this new number to the back of our list. So list append new number. So here, let's print our list and let's see what happens. So let's say fib 8. So let's run this, and we are going to get 0, 1, 1, 2, 3, 5, 8, 13, 21, 34. So here, notice that fib 8, I'm supposed to get 13, but we generate until 34. So here, we actually need to do this, n minus 2. So if you run this, we are going to get 13. So instead of printing our entire list, we can return the last thing in the list. So list index minus 1. So let's print 8, and we'll get 13. So if we do it for 9, we'll get 21, and if we do it for 10, we are supposed to get 34. And here we have it, so this is the correct answer. However, there's also an alternative way that we can do this without creating a whole list just for this. So here in coding interviews, you might be asked to optimize the space complexity, which means how much space that your function takes. So here we create a list, which means that we are taking additional space. And next, we can try to optimize this space complexity. So let's get rid of this. And let's define fib once again, fib n colon. So here, once again, if n is equals to 1, we return 0. And if n is equals to 2, we return 1. So these are the default values. So let's get them out there. And next, we can create a bunch of variables. So let's say a is equals to 0 and b is equals to 1. And for I in range n minus 2, we have c is equals to a plus b, a is equals to b, and b is equals to c. So let's check out what's happening here. So a is equals to 0 and b is equals to 1. So this is the first iteration, and c is equals to a plus b, which means that c is equals to 1. A is equals to b, so now a becomes 1, and b equals c, which means b becomes 1 still. So this is the first iteration. So in the second iteration, a is equals to 1, b is equals to 1, and c is equals to 1. C is equals to a plus b, which means that c now is equals to 2. A is equals to b, which means that a is equals to 1 still. And b is equals to c, which means that b is equals to 2. In our third iteration, a is equals to 1, b is equals to 2, and c is equals to 2. So first things first, c is equals to a plus b over here, which means that now c is equals to 3. A is equals to b, which means that now a is equals to 2, and b will take c's value, which means that b is equals to 3. And next, in our fourth iteration, a is equals to 2, b is equals to 3, and c is equals to 3. C is equals to a plus b, which means that c is now equals to 5. And a is equals to b, which means that a is 3, and b will take c's value, which now means that b is equals to 5. So here, notice that c becomes 1, 2, 3, 5, and so on. And after this, c is going to become 8, which means that our variable c is actually taking the values of the Fibonacci numbers. So with this in mind, let's actually try to write this out on our code. So similarly, if n is equals to 1, I'm going to return 0, and if n is equals to 2, I'm going to return 1. So here I have a is equals to 0 and b is equals to 1. And for I in range n minus 2, c is equals to a plus b, a is equals to b, and b is equals to c. And at the end, I'm going to return c. So let's put this into practice. So for I in range, let's say 1 to 10, and we print fib I. And let's put n is equals to empty space so that we can see them all in one line. And here we have it, 0, 1, 1, 2, 3, 5, 8, 13, 21, and 34. So here, using this method, we don't have to maintain a list like our previous method, and this is more efficient space-wise. So once again, thanks for watching, and hopefully this was clear and easy to understand. See you in the next one.